Welcome to KVK Learning. In this video, we are going to discuss about number system and its conversion. There are four types of number system: binary number system, decimal number system, octal number system, and hexadecimal number system. Now consider binary. We know that binary base is nothing but 2. It will contain, let us consider r is equal to 2. It will have 0 and 1 as input. Binary will have only, the reason is in binary the representation is 2. The number of elements can be decided based on n is equal to 0 to r minus 1. Since r is equal to 2 here, n is equal to 0 to r minus 1. 2 minus 1 is nothing but which is equal to 0 comma 1. This is the number of elements. So 0 and 1 is the elements used in binary number system. Then the second one is decimal. We know the decimal means 10. Now r is equal to 10. N is equal to 0 to r minus 1. So therefore 0 to r 10 minus 1 is nothing but 9. Therefore it will contain 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the number of elements used in decimal number system. Then coming to octal number system, we know octal means 8. So therefore r is equal to 8. Then n is equal to 0 to 8 minus 1, which is equal to 0 to 7. Therefore 0, 1, 2, 3, 4, 5, 6, 7. Only these numbers will be used in octal number system. The next one is hexadecimal number system. Hexadecimal number system is nothing but 16. So therefore base is 16. R is equal to 16. Therefore n will be 0 to 15. So it will contain till 15. 0, 1, 2, 3, 4, 5, 6, 7. We'll continue here. 8, 9. Here we will not use 10 directly. Instead of 10, we will be using A, B, C. A means 10, B means 11, C means 12, D is 13, E is 14, F is 15. So this is the numbers used to represent hexadecimal number system. I think you have understood the basic number systems. Now let us discuss about the conversions. First we will discuss about decimal to other base conversion. The first one is decimal to binary. Let us consider this example. 15, the base is nothing but 10 for decimal. So I have given 10 here. We have to find out the binary equivalent of this decimal number. How to calculate the binary equivalent of decimal number? You have to write the 15 here. Since the binary base is 2, we have to divide this number by 2. 2 7s are 14. So the remainder is 1. Then again you have to divide by 2. 2 3s are 6. Again the remainder is 1. 2 1 is 2. So the remainder is 1. How to represent the binary equivalent? We have to represent the binary equivalent in the form of lower to upper one. From here to here. That is nothing but 1, 1, 1, 1 of 2. This is the binary equivalent. Therefore, 15 binary equivalent of decimal number 15 is nothing but 1, 1, 1 of 2. 2 is the base number. I think you have understood this. Now let us consider another one example. See, in this example we are having a decimal number. This is also same. First we have to consider only the integer. We will not consider the decimal number now. Similarly we have to divide by 2. 2 3s are 6, so 30. Remainder is 0. Again divide by 2. 2 into 15, 30. Again the remainder is 0. 2 7s are 14. Remainder is 1. 2 3s are 6. Again the remainder is 1. 2 1 is 2. Again the remainder is 1. So that's it. Here 1 came. So again you have to write from bottom to top. Therefore the binary equivalent of 60 is 1 1 1 1 0 0. But we have to find for 35. How to find for 0.35? Write as 0.35. For 60 we have divided by 2. But for after decimal point means then we have to multiply the number by 2. 0.35 into 2 is equal to 0.70. We have to continue the process until we'll get an 1. It should be equal to 1, not like 1 point something or thing. So again divided by 0.70, multiply by 0.70 into 2, which is nothing but 1.40. Then again see 1 came here but we are having 0.4. So again take this 0.40 and multiply by 2, which is nothing but 0.80. The process goes on. 0.80 into 2, which is equal to 1.6. Again take 0.6 into 2, which is nothing but 1.2. Again take 0.2 into 2. So which is nothing but 0.4. So again the process repeats. Since 0.35 and 4 is similar, I am stopping at this point. So the binary equivalent of this decimal number is, like after the point is, how we have to write means, we have to consider only the digits before the point. So we have to write it from top. 0, 1, 0, 1, 1, 0. So therefore, the binary equivalent of 60.35 decimal number is 11110. Since we are having decimal here, we have to keep the decimal and then we have to continue this number 010110 of 2. This is the binary equivalent of the decimal number 60.35. Now we will discuss about decimal to octal number system conversion. Consider the number 15 of 10. We have to find out the octal equivalent of the decimal number. First write 15. Here also we have to follow similar process how we used for decimal to binary. There we use 2, since 2 is the base of binary number. Here octal base is 8. So we have to divide by 8. We know 8 1 is 8. Remaining is 7. Therefore, the octal equivalent of this number is 17. 17 of 8. Therefore, 15 of base 10 is equal to, the octal equivalent is 17 of 8. Then let us discuss the second example, 60.35. Here it have the number after the decimal point. For this, similar like binary, how we found binary, we have to use for octal also. For 60 we have to find first. 8 sevens are 56. So the remaining is 4. Therefore the octal equivalent of 60 is 74. 74 of 8 base. Then we have to find for 0.35. Here we have to multiply by 8. 0.35 into 8 is nothing but 2.80. Then again we have to write 0.80 into 8. Which is nothing but 6.4. Again 0.4 into 8. Which is nothing but 3.2. This goes on like this. So we can write, this is the octal equivalent of this decimal number. So we have to write it like 263 of 8. Therefore, the octal equivalent of 60.35 of base 10 is nothing but 74.263. Base is 8. I think you have understood this. Then the next topic is decimal to hexadecimal. First consider the example 50. As we know, the base of hexadecimal is nothing but 16. So here we have to divide the number 50 by 16. 16 threes are 48. The remaining is nothing but 2. Therefore, the hexadecimal equivalent of 50 is nothing but 32. We represent this as 50 of base 10 is equal to, hexadecimal equivalent is nothing but 32. We have to write it with the base 16. Next example is nothing but 58. Similarly, divide 58 by 16. 16 threes are, we know 48. So the remaining value is 10. So therefore we have to write it as 3 and 10. But in hexadecimal we know A is nothing but 10, B is 11, C is 12, D is 13, E is 14, F is 15. So instead of 10 we have to write it as 3 A. So therefore the equivalent is 3A of 16. Therefore the hexadecimal equivalent of decimal number 58 is nothing but 3A of 16. Then we'll consider the another one example, which is nothing but 60.35. Similarly, we have to find out for 60 divided by 16. Again 16 threes are 48. The remaining is 12. We have to write this one. 3. The equivalent of 12 is nothing but C. So I will be writing as C. 3C of 16. We have to find it for 0.35 also. So 0.35 means for decimal digits we have to multiply by the base of the equivalent one. So 0.35 into 16 is nothing but 5.6. Then again 0.6 into 16, which is equal to 9.6. Again 0.6 into 16 is equal to 9.6. It goes on like, so therefore we can write it as this one. We have to write for the hexadecimal equivalent 599. Therefore 60.35 of base 10 is equal to, hexadecimal equivalent is nothing but 3C.599 of 16. I think you have understood the decimal to other base conversion. In the upcoming videos, we will be discussing about the other number system conversion. Thanks for watching. Please do like, share and subscribe KVK Learning channel. Don't forget to press bell icon.